Hello, 108 students. Mr. McCube back here with you for section 2.6. We're working with compound inequalities, and we're going to tackle page 2 here. And we're now going to work with OR, and we're going to remember that it is the union. OR is union, and you're going to remember the U, and when you see A union B, you're going to think of the word OR, which means one solution or the other, or mean both of them all added together. So here's an example back with set A has the numbers 1, 2, 3, 4, just like we had back in the last page. Set B has 2, 4, 6. Now they ask for the union of them. Think of putting them together. So all the numbers that you see in both sets have to be in the solution set. So 1, 2, 3, 4 have to be part of it, and what's in set B that's not in there. The 2 is already there, it's counted for. The 4 is counted for, but look at the 6. It was not up in solution set A, so you bring it down, and that's your answer. Okay, so with that concept here, we're going to do a couple examples. Going to look at objective 4, inequalities with the word or the union. Now again, the strategy is take each inequality, isolate, find the value of x that makes that inequality true, do it for both of them, and then you're going to do the union and adding or putting together both solution sets. Okay, so real quick, let's take this one and ask yourself, what do you do to isolate the 6x term? You're going to, isolate the 6x. What am I saying? What can you do to combine the x terms? So you're going to minus 2x on both sides. Remember to always do the smaller one. Here's a 0. It's okay to have a 0 on one side of the equation. 6x minus 2x is 4x. Now you ask, what do you do to isolate the 4x? Add 4 to both sides. You get 4x is less than 4. Last step, the closer, the coefficient, divide by it. It's a positive 4, so leave this inequality alone, and you come up with the solution x is less than 1. You graph that. Okay, graph that, you're going to the left. Or means union, take negative 3x less than or equal to negative 9. So now watch yourself, going to divide by negative 3. So what should happen? Warning, 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 warning. What do I do with the inequality sign? That's right, switch it. So you've got x greater than or equal to, now careful, negative divided by negative is a positive. So all of x such that x is greater than or equal to 3 would be done with brackets, and you're going to the right. Okay, now you need to merge those two together. And many times when you do the union of these, I tell my class they look like seagull wings. They look like a bird up there flying, and there's the left wing, here's the left wing, here's the right wing, and you've got a gap in the middle. So you just simply bring those two solution graphs down, and there you combine them, and you're good to go. Okay, so let's try it. Let's try another one. A lot of times they look like that way, but they don't always have to be. Oops, excuse me. What the heck here. Okay, let's go down to example 8. Starts off, let's take the first inequality, isolate the x. Okay, minus 5 on both sides. Now we are going to divide by negative 2. Warning, you know the drill. If you divide or multiply by a negative sign, switch the inequality. Good job there. You get x less than or equal to negative 3. And so I graphed it over here. Here's your negative 3. You include it. You're going down. Okay. They ask for OR, which means union. And now you take the inequality, the second inequality, and isolate or solve for x. Okay, add 7 to both sides. And you get 4x greater than or equal to negative 20. Remember, negative 27 plus 7 is negative 20. Now, isolate the x, divide by a positive 4, and negative divided by a positive 4 is a negative 5. Sorry about the barking there. X greater than or equal to negative 5. Those are my neighbor's dogs going crazy. Okay, now, union. You have to put both solutions together, so come down on the graph. Here's the negative 3. You went this way. Okay, going all the way towards negative infinity. Over here we're starting at negative 5 and we're going towards positive infinity. And when you do that, you graph it. You ask yourself, what are all the elements on this graph, on this line? Starting from negative infinity, going all the way to positive infinity, and bingo, there's your set notation. Okay, so section 2.6 shouldn't be too bad for everybody. We'll move on to section 2.7 when I see you guys next, and we will work with absolute inequalities. Okay, so Mr. McHugh signing off for now, and I will catch up with you on section 2.7. Okay, bye.